Hey guys, this is T here with another video, Quadratic Functions, this time problem solving. So in the previous video we talked about how quadratic functions can describe relationships between variables in many real life situations, usually things involving a parabola, like parabolic paths, that sort of thing. So we also talked about how substitution and techniques to solve quadratic equations can be used to solve these kind of problems. So let's run through an example there because I didn't do a problem solving example in the previous video. So let's say a stone was thrown into the air and you found that the parabola that stone thrown in the air makes can be graphed or given by the function h of t is negative 5t squared plus 30t plus 2, where h is the height in meters above the ground and t is the time in seconds after the stone is thrown. So this function here that you're given relates the variable height above the ground of a stone that's been thrown over a certain time in seconds. So let's solve these problems here. We've got three questions. How high above the ground is the stone after 3 seconds? So it's asking how high the result of your function is giving you the height. So we're solving for essentially what y is given a certain amount of time. So this is a substitution. It's the simpler thing. You're just plugging in the variable because you're given it as 3. So you're finding h of 3. It's going to be negative 5 of 3 squared plus 33 plus 2. 3 squared is 9, times by negative 5 is negative 45, plus 30 times by 3 is 90, plus 2. Negative 45 plus 90 is 45, plus 2 is 47. Therefore, after 3 seconds, the stone is 47 meters above the ground. So like we showed in the previous video, questions where you're given the unknown are easy because all you do is find the function given that. You find h of 3 in this example here. B, from what height above the ground was the stone released? So we're still trying to find the height, so it's still a substitution, but it doesn't directly tell us what the variable is. It's not saying how many seconds it is. But when was the stone released? Well, t is the time in seconds after the stone is thrown. What's the time when the stone is released? Well, t at release is 0 seconds. That's just logic there. At the exact point that you're releasing the stone, it's 0 seconds from when you released it in the first place. So you are finding h of 0. This time it's negative 5 lots of 0 squared plus 30 lots of 0 plus 2. 0 squared is 0, times by negative 5 is 0, plus 30 times by 0 is 0, plus 2, 2. So what that's saying is, at release, the stone was at 2 meters. So I'm guessing they're pretending it was thrown by a person or something. It's not like it's being launched from ground level with a cannon or some sort of thing like that. So that was that, having a bit of a thought process to work out what the value of the variable was instead of being given the number. Alright, C. At what time is the stone 27 meters above the ground? So you're trying to find the time. You're finding the variable this time, and you're given the height. So this is one of the solving examples because you're given the height, 27 meters. And it is equal to negative 5 lots of t squared plus 30t plus 2. We're trying to work out what t is. Alright. So we need to solve this using our techniques from before. I'm going to rearrange it. I'm going to put everything on the left hand side that is on the right, so negative 5t squared plus 30t plus 2 is equal to 27, so I just switched them around. I need to get 27 on the left hand side, so negative 5t plus 30t plus 2. The opposite of positive 27 is negative 27, so taking 27 from both sides is going to clear the right hand side for me. So 5t squared plus 30t, 2 take 27 is negative 25 is equal to 0. So now we're in the form ax squared plus bx plus c is equal to 0, except for the negative 5 at the front. I can't use my solution, I can't use my techniques if it's negative ax squared. I can only do it if it's ax squared. So what you may notice here is negative 5 is a factor in all of these numbers here, so I'm going to take it out. If I remove negative 5 from all of the terms here, what did I times negative 5 by to get negative 5t squared? T squared. What would I times negative 5 by to get positive 30t? It would be negative 6t. Why? Because negative 6t times by negative 5 is going to give you positive 30t. What did I times negative 5 by to get negative 25? 5 times 5 is 25. To make it negative, it'd have to be positive 5. So a factor removed. I've removed negative 5 from all of the terms. And then what's the sign between the negative 5 and the brackets? A times. So if I divide both sides by negative 5, it'll get rid of the negative 5. And 0 divided by negative 5 is still 0. So what am I left with? T squared take 6t plus 5 is equal to 0. So let's try using the flowchart idea. Sum product rule, 1 times by 5 will give me positive 5. It won't give me negative 6, but negative 1 times by negative 5 will give me positive 5. Negative 1 plus negative 5 will give me negative 6. So that's my A, that's my B. So T take 1, T take 5 is equal to 0. Therefore, T is either equal to, T take 1. Let's do all the steps instead of skipping. T take 5 is equal to 0. This is never ending. T can either be 1 or T can either be 5. Therefore, stone is at 27 meters above ground at 1 second or 5 seconds. Now you might wonder why there are two results. Does that even make sense? Well, yeah, it should, because in previous questions here we worked out that the stone is thrown from 2 meters above ground. What happens when a stone is thrown? It goes up and it comes down. So there should be two results. After 1 second you're saying it's 27 meters above ground, and then there's going to be a point on the way down where it's also instantaneously again at 27 meters above ground. Obviously this isn't to scale, but let's say that that is 27 meters in height. There's going to be 2 points on the parabolic trajectory of this stone that are going to be 27 meters above the ground. Therefore, 2 results, 1 second and 5 seconds. Alright, so hopefully that helps you out with the idea of problem solving using quadratics. Yeah, it's pretty interesting. If you're looking into doing physics later on, this might be something that you try to understand, try and get good at. And hopefully I'll see you in the next video.